Hello everyone, in this video we're going to be talking about feasibility analysis. When a new systems project starts, several questions come up. Is this project really worth doing? Can we actually do this project? Will the organization accept this project if we go ahead and complete it? These are important questions that must be answered, and the feasibility analysis is how we begin to address these questions right from the get-go of the project. The learning objectives of this video are as follows. After watching, students should be able to describe technical, economic, and organizational feasibility assessment. They also should be able to perform a feasibility analysis on a new project. A feasibility analysis is a detailed business case for the project. It outlines the benefits, costs, and risks that are associated with the project. Feasibility analysis can be divided into three key components: technical, economic or financial, and organizational. We'll talk about each of these three in more detail. These three together are compiled into a feasibility study. And it's critically important to reassess feasibility throughout the project as things change and costs and benefits become more clear. First, let's talk about technical feasibility. In other words, can we actually build this system? There are several sources of risk associated with technical feasibility. First, users and analysts' lack of familiarity with the business application area. For example, if an organization needs a sales management system, and the systems analysts and programmers have never worked in sales, there's a source of risk because the technical staff may not understand some of the key needs of the system. Obviously, one way to mitigate this kind of risk is to have the technical staff interact on a regular basis with the sales staff as they are implementing the project. Another source of risk is lack of familiarity with technology. Questions to ask are, have we used this technology before? How new is it? Another source of risk is the project size. Large projects are more complex and risky, technically speaking, than smaller projects. Project size can be determined by the number of people, how long it will take to complete the project, how many distinct features are involved in the project, and so forth. One last area of risk that I'll mention is compatibility with existing systems and the degree of integration that is required. Does the system that you're building have to integrate directly with another system? For example, if you're building a sales system, will it have to integrate with your accounting system? These are all questions that must be addressed in the technical feasibility analysis. You must list each source of risk specific to the project, as well as analyze how that risk can be dealt with. The second key area of the feasibility analysis is economic feasibility. Should we build it? Will the benefits outweigh the costs? Is the final question. In doing a feasibility analysis, you need to first sit down and assign specific dollar values to costs and benefits, determine the cash flow, and assess the financial viability. This isn't an accounting or finance course, so we won't go into detail about the numbers and equations, but some values that should be involved in an economic feasibility analysis are return on investment, or ROI, a break-even point, and a net present value. Please refer to the textbook of Chapter 1 for more information on how to calculate these. You won't be asked to calculate these on any exams or quizzes, but you should at least include a return on investment value when you do an economic feasibility homework this week. This is a good table from the textbook that gives examples of development costs, operational costs, tangible benefits, and intangible benefits. Tangible benefits are those that have an actual dollar value associated with them. Intangible benefits do not. Intangible benefits aren't included in dollar-specific cost-benefit analyses, but they should be highlighted in footnotes and in the text part of your feasibility analysis. There are two types of costs: development costs and operational costs. Development costs are those that occur during the building of the system, for example, paying the programmers who are building the system. Operational costs are those that are ongoing once the system is already in place, such as continuing licensing and training. Here's an example of what a cost-benefit analysis looks like. You'll be required to do one of these for your homework. You can see at the top, benefits are listed in dollar values, then costs are broken into development and operational costs, with totals at the bottom. Cost-benefit analyses are usually performed to consider the first 3 to 5 years of a system. You'll see in this example that 2015 is the year the system is being built. That's when all the development costs occur. And then once it is built by the end of 2015, it will be in operation starting in 2016. So they've listed the first 4 years of the system being in operation. In this example, they've decided that increased sales and reduction in inventory and customer complaint calls will be tangible benefits that will result directly from implementing this system. The development costs include hardware such as servers and printers, and software such as server software and software licenses. They've also included a cost for development labor, which refers to the salary of programmers, technical staff, and even the systems analysts. Operational costs often include hardware, software, as well as any labor that is associated with running the system. This could include IT support, for example. The third and final key area of a feasibility analysis is organizational. It's important to think about strategic alignment. Are the project goals aligned with the business strategy? In cases where you've started an IS project just because you want to implement a new and cool technology, this might not align really well with what your business is trying to do. Strategic alignment is key. Think about the effect that the project will have on various stakeholders who use the system. Is there a strong and influential project champion? Is there strong and widespread support from upper management? Are there any users who will be particularly receptive or not receptive to using the system? All projects have feasibility risks. Our goal is to know those risks that we face and the significance of those risks and ways that we can mitigate them. The project sponsor, the project manager, and other team members need this awareness in order for the project to succeed. Once risks are known, steps can be taken to mitigate them. For example, if one risk is that your organization is not familiar with a new technology being implemented, you can take several steps to mitigate this. You can provide a budget for training. You can provide a budget to hire consultants who do have expertise. You could allow more scheduling time in the project to allow for a learning curve, and so forth. It's essential to continuously review and revise the feasibility assessment throughout the project. Examine how well you're managing risks that you previously identified and if adjustments are needed. Are there any new risks that have appeared? Pause for a minute to think about this question. It's estimated that around 50% of large systems development projects fail. Why do you think this is so common? Missed deadlines, scope creep, poor planning, all of these are things that happen when the project is not carefully and correctly planned ahead of time. That is why the planning phase of the systems development life cycle is so critically important. In this video, we've described technical, economic, and organizational feasibility assessment and issues, and you should be able to perform a feasibility analysis for a new project.